In this lesson, I'll teach you how to solve kinematic motion in one-dimension physics problems. This is question 1. The question reads, a train starts from rest at position 0 and moves with constant acceleration. At first observation, the velocity is 20 meters per second, and 80 seconds later, the velocity is 60 meters per second. At 80 seconds, calculate the position, average velocity, and constant acceleration over the interval. Let's begin by answering these. Now, for convenience sake, I've written down some very important formulas that we'll be referring back to throughout this question. In order to calculate the position and average velocity, I think we need to calculate the constant acceleration. And for that, we'll use this very first formula, where v represents the final velocity, and we know the final velocity is 60 meters per second. So let me write down everything we know actually. We have vf, or you can just leave it as v because these formulas are representing v as your final. You don't need this f, but if you feel comfortable, leave it. 60 meters per second. We know v sub 0, that's the initial velocity. So I'll write down the v sub 0 is 20 meters per second. In addition, it's 80 seconds. It's written right there and right there. So that's the time, 80 seconds. Let me substitute these values in and isolate for a. Or you can isolate for a first and then substitute the values. So to solve for a, we will move that over and we'll worry about that t later. So v minus v sub 0 is equal to a t, and then divide both sides by t. And now we have a isolated, which represents the constant acceleration. Okay, now it's time to substitute my values. I have 60, that's an arrow, 60 minus 20 over t, which is 80. Now some teachers will expect you to write down the units throughout the calculation, so I'll show them as well. We have meters per second, and seconds. 60 minus 20 is 40 meters per second divided by 80. So we're dividing by 80 seconds. Now, if we're dividing by 80 seconds, that's the same thing as 80 seconds over 1. So we flip this, and we get 40 meters per second multiplied to 1 over 80 seconds. Multiplying out these two fractions is not hard. We have 40 times 1, that's 40 meters per, and there's a seconds unit, so 1 second times 80 seconds is 80 seconds squared. 40 divided by 80 is 0.5 meters per second squared. That right there represents the constant acceleration. Now the reason why we needed the constant acceleration first before we can calculate the position is because to calculate the position, we will be using this formula next. And this formula requires that we know the acceleration. So with that being said, let's calculate the position next. We will use this formula. We already have x sub 0. That represents the position at the very beginning, which is 0. It says right here, position 0. So x sub 0 is equal to 0, and we're looking for x, which represents the final position. Calculate the position at the very end. All right, let's go ahead and do this. We will substitute 0 into there. And if we actually do that, we end up with simply x. So that's the final position, is equal to v sub 0. That's 20 meters per every 1 second times t, 80 seconds. How convenient is that? Look, the seconds unit right away cancels out. We don't have to worry about that. Plus half of the acceleration, which we found to be 0.5 meters per second squared. And lastly, times t to the power of 2, which is 80 seconds raised to the power of 2. Okay, let's start by multiplying these out. 20 times 80 is 1600 meters plus half, and 80 seconds squared, that's the same thing as saying 6400 seconds squared, 0.5 meters. And look how convenient this is. The seconds squared right here, it actually cancels out with this one, leaving us with Well, let's use our calculator. We have 1600 meters plus 0.5, representing this half, times another 0.5 times 6400. That gives us 3200, which means that the position 80 seconds later is 3200 meters. Now the average velocity we will be using, well, the formula isn't written here, and it doesn't really need to be because finding the average is easy of any two numbers. You take the final plus the initial and divide it by 2, and that's the case always when you take the average. So essentially I can take 60 meters per second plus 20 meters per second and divide by 2, and that should give me my velocity, my average velocity. 20 plus 60 divided by 2 is 40. 40 meters per second will represent the average velocity. Now if you multiply this number by 80 seconds, you will actually get 3200, which we found over here, and that would represent the final position. Okay, let's quickly answer the rest. Calculate the position of the train at 20 seconds. Okay, for convenience, I've written down the important formulas again. They want us to find the position of the train at 20 seconds. So the final position at 20 seconds, no problem. We'll write down x minus the initial, which we discussed was 0. So x is equal to the initial velocity, that was 20. And I'll ignore the units because you know how they cancel out now. So 20 times 20 seconds plus 0.5, representing that half. The acceleration was 0.5 as well, and 20 seconds squared. So I'm deliberately not writing down the units because it just gets repetitive. So 20 times 20 plus 0.5 times 0.5 times 20 raised to the power of 2. And that's 500. 500 meters after 20 seconds. Find the time required for the train to reach 100 meters. So same formula, except x will be 100 is equal to 20, which was the initial velocity, and we're finding the time, so t is going to be blank, plus 0.5, 0.5, and t is going to be blank again. This is actually going to end up with a quadratic. That might be problematic if you don't know how to solve quadratics, but I'll give you a rundown anyway. I'll bring the 100 over. I have 0 is equal to negative 100 plus 20t. 0.5 times 0.5 is equal to a quarter, and you can test that on your calculator. So you end up with 0.25 t squared, and hopefully you know how to use the quadratic formula. I'm going to assume that you already know how to use it, so I'll use a function on my calculator that will help me solve quadratics. And what you do is you type in the coefficient 0.25, 20, so you type in this as A, that as B, and that as C, and negative 100, and you're going to end up with two solutions, either 4.72 seconds, or negative 84 seconds. That makes no sense, so we will omit negative 84.7. We'll be omitting that one, and we'll assume that that right there is our answer. To the correct number of significant figures, you can argue that this is 4.7 seconds, and you can omit this 2 as well. And finally, find the velocity of the train at 120 meters. I'll be using this formula because it relates the position and the velocities. We want the final velocity, so this thing, v squared is equal to 20 squared plus 2 times the acceleration, x minus x sub 0. We know that it will reach 120 meters, so that's the first one, and it starts at position 0. This is not bad. I'll do the right side very quickly and then square root whatever I get because we have a squared here. We have to square root both sides. So I have 20 raised to the power of 2 plus 20 times 0.5 times 120 gives us 520. And like I said, we need to square root that. And if we do, the square root is 22.8. So the velocity was 22.8 meters per second at 120 meters. If you want this to 3 significant figures, or if you want this to 2 digits, you would round to 23 meters per second. And there you have it. That is our very first solution to kinematic motion in 1D problems. Make sure to watch questions 2 and 3 for more examples. We'll see you soon.